Hi boys and girls. Today we're doing our problem solving lesson and it's on changing dimensions. Now if you remember our problem solving lesson, we don't usually learn anything new, but what we do instead is we learn how to apply it in a different way. And so I want to talk about dimensions really quick. Dimensions, boys and girls, is really just another way of saying measurement. And as you can see, I've kind of crossed out dimensions and I wrote the word measurement to help me remember that that word dimension, it really means measurement. So for example, right here, I have a rectangle that's 4 inches by 3 inches. And so the dimensions or the measurements of that rectangle, we would say that's a 4 by 3. And so we're going to talk about what happens when we change those dimensions. What happens to the area of our shape? So reading the problem today, it says, Jason has created a 3-inch by 4-inch rectangular design to be made into mouse pads. To manufacture the pads, the dimensions will be multiplied by 2 or 3. How will the area of the design be affected? So what that means, boys and girls, is we're going to take these dimensions and we're going to make them twice as big because we're multiplying them by 2, or we're going to make them 3 times as big because we're going to multiply them by 3. Now, you know I don't love this part of our graphic organizer, but we are going to look down here to our table, and we're going to see what happens as we make those dimensions just a little bit bigger. Okay. All right, so our original shape was 3 inches by 4 inches. And if we do nothing, if we don't multiply it at all, we just keep it the same as 3 by 4, the area of that rectangle is going to be 12 inches squared. Okay, let's see what happens, boys and girls, when we use a multiplier of 2, meaning we're going to make those dimensions twice as big. So instead of a 3 by 4, twice as big means now we have 6 by 8, right? Because I made those twice as big. So I times my 3 by 2 and I also times my 4 by 2. Okay, so that's going to change my formula to be area equals, the length now is 6 and the width is 8, and 6 times 8 is 48 inches squared. Okay, so when we look at that, boys and girls, we made our shape, our dimensions twice as big, which might make you think, oh, well, that's going to make my area twice as big. But twice as big as 12 would actually be 48. So I want you to, or twice as big, 12 twice as big would be 24. So why is my area now 48? I want you to think about why would that possibly be? Okay, let's look over here and see what happens, boys and girls, when now, instead of having our dimensions be 3 by 4, let's make them 3 times as big. So if we make a 3 times as big, we're going to have a shape that's 9 inches by, if we make a 4 3 times as big, it's going to be 12 inches. Okay, so we multiplied both of those values by 3. And plugging that into my formula, area equals length times width, area equals 9 times 12, which is 108 inches squared. Okay, so why is it, boys and girls, that when we double our dimensions, the area actually gets 4 times as big? Why is it that when we triple our dimensions, it's not just triple the area? Okay, the reason why is because we're multiplying both of the dimensions. Okay, we made both of our numbers bigger, which makes our area 4 times as big. here where we made both of our dimensions bigger, instead of it being 3 times as big, now it's 12 times as big as what we originally started with. So when the dimensions are multiplied by 2, the area is actually multiplied by 4. When the dimensions are multiplied by 3, the area is actually multiplied by 9. Okay? Because what we're doing actually, boys and girls, is we're squaring it. Okay? Meaning that we do it to both sides of our rectangle. Okay? Let's look on the back. Okay? This time, instead of making it bigger, we're going to make it smaller. It says a stained glass designer is reducing the dimensions of an earlier design. Reducing, maybe meaning that we're making it smaller. The dimensions of the triangle shown will be multiplied by a half or a fourth. How will the area of the design be affected? Use the graphic organizer to help you solve the problem. So down here, boys and girls, we're going to use our chart to help us see how that area is affected. Okay, so starting with just a regular triangle, Okay, we had dimensions of 6, our height was 6, and our base was 16, and that's centimeters. Okay, and so when we plug that into our equation, 1/2 base times height, we get 1/2 times 16 times 6. Okay, 1/2 of 16, boys and girls, that's 8, and 8 times 6 is 48. So just finding the area of that original triangle, that was 48 centimeters squared. Okay, this time it's saying, well, what if we just figure out what half of the dimensions are? What if we take that 6 and that 16, and instead of using those numbers, let's make it smaller. Let's do it half as big. So 1/2 of 6 is 3, and 1/2 of 16 is 8. Okay, so we're going to use that formula again for a triangle. Area equals 1/2 times the base is 8 times the height is 3. Okay, so 1/2 of 8, boys and girls, that's 4, and 4 times 3 is 12. Okay, so here we cut these in half, right? 16 went to 8 and 6 went to 3. And yet our area, boys and girls, 48 to 12, that's not cut in half. That's actually divide by 4. Okay, so this was divide by 2, right? And that gave us 8. This was divide by 2, which gave us 3. And yet our area was actually divided by 4. Okay? The next one it asked us to do, boys and girls, is it asked us to do a multiplier of a fourth. So what happens when these original numbers are a fourth as big? So if I were to find a fourth of my original dimensions, which were 6 by 16, a fourth, boys and girls, means that we're going to break this 6 into 4 equal parts. And I know that breaking that 6 into 4 equal parts, that's going to make my height of my triangle, boys and girls, that's going to be 1.5 centimeters. And a fourth of 16, if I break 16 into 4 equal parts, that's going to make each of those 4 centimeters. Okay, so let's see what happens. I want you to be thinking, what's going to happen to the area of that triangle now that we are doing it a fourth as big? So using that formula, 1/2 times 1.5 times 4. equals, now I'm going to go to my handy dandy calculator, boys and girls, because doing that kind of math in my head is a little bit hard. So 0.5 times 1.5 times 4, wasn't it 4? Yeah, equals, okay, now that dimension, boys and girls, is 3 centimeters squared. And this, I should have labeled this. This was centimeters squared. So we went from 48, when it was half as much, it went down to 12, which was divide by 4. And now, boys and girls, we went half as much again to a fourth, and now it's divide by 4 again. Okay? So when the dimensions are multiplied by a half, the area is multiplied by a fourth. When the dimensions are multiplied by a fourth, the area is multiplied by 1/16. When the dimensions are multiplied by 1/16, oh no, sorry, that was bad. Sorry, that's the answer. It's 1/4. When we multiplied the dimensions by a fourth, the area is multiplied by 1/16. Okay, so every time, boys and girls, our dimensions, the area is squared. Whatever it was that we did, right here, it was a half times a half. That made our area a fourth. Okay, here, a fourth times a fourth. That made our area 1/16. Hope this helps.